My name is Zira, I am also from Microsoft, and will be taking over from David in this session. In the last session, you were asked to set up and comment on a definition for heat transfer. The following is a definition that I would propose for this course. A point is a position in three-dimensional space, that can be specified by values of the coordinates, x, y, and z. Can you tell me whether the heat flows from a low to a high temperature, or do you think it flows from a high temperature to a low temperature? What do you think? A high temperature implies that molecules at that point have a lot of energy, and you can imagine that some of the surplus energy can be transferred to another point with less energy. Consider 1 joule of energy, that is being transferred from point 1 to point 2, in 2 seconds, as shown in the animation. What is the heat transfer rate in watts? Well, if 1 joule is transferred every 2 seconds, it means that only half a joule is transferred every second, so the heat transfer rate would be half a watt. In the last session, you were asked a question about the different modes of heat transfer. In this session, you will be given some examples of the modes. Also, the mechanisms whereby heat is transferred will be explained to you. In a following session, you are going to look at how to calculate heat transfer rates for each mode. I would like to use a hot iron, as an example, for each of the 3 modes. Say, you are ironing a shirt, and when you are finished, you put the iron on its tail. In this slide, you are just holding up your hand in front of the iron. Even though your hand can be far from the iron, it will feel like it's getting hotter. This means that heat is being transferred to your hand from the iron as indicated by the arrow. This mode of heat transfer, where heat seems to cross an empty space, is called radiation. Another example of radiation is if you are outside on a sunny day, when you will probably feel the radiation from the sun on your exposed skin. In this slide, you move your hand to above the hot iron. You would then feel air passing your hand from the bottom. Am I right? Did you ever feel the warm wind above a hot object? The air moves up as the air molecules, oxygen and nitrogen, next to the hot iron surface heat up. This gives them more energy, they bump more against each other, and hence move further apart. This causes a decrease in density, so the heated air becomes lighter, and then flows up as shown in the animation. In the previous session, most of you matched convection with heat transfer between a moving fluid and a surface. Well done. In the animation on this slide, where does convection heat transfer take place? Is it between the hot iron surface and the air molecules? Or is it between the air molecules and your hand? What do you think? Convection by the iron, or convection by your hand? Convection heat transfer takes place between the iron surface and the air molecules as they move by, as the air is heated up. Convection heat transfer also takes place between the air flowing past your hand and your hand surface, as your hand is being heated up. So convection happens, and at both positions. This slide is not for sensitive viewers, as it contains a scene that may cause you distress. You accidentally push your hands against the hot iron. Your skin heats up to the temperature of the hot iron, and the molecules of your flesh below the skin transfer the heat deep into your hand, rapidly heating at the same time. Your nerves sense the heat and transmit pain signals to your brain. Heat is therefore conducted deep into the flesh of your hand. To summarize, you have been introduced to 3 types of heat transfer. Conduction, which is heat transfer by adjacent molecules. Convection, which is heat transfer from a surface to a moving fluid, or from a moving fluid to a surface. And radiation, which is heat transfer through empty space or gas. You are now going to be introduced to the mechanisms at work in each of these 3 modes of heat transfer. This slide is an animation of conduction heat transfer, and may represent the cross-section of a wall, for example. On the left-hand side, you see a heat source. This could be a heater that emits energy. On the right-hand side, you see a heat sink. This could be cold air and cold surroundings on the right-hand side of the wall that suck heat out. The blue orbs represent the molecules in the wall. The left-hand side molecule moves to the left and bumps against the heat source, picking up 1 joule of energy, for example. It then recoils to the right, bumping into the next molecule, in the process passing on the 1 joule of energy. The second molecule picks up the energy and passes it on to the next molecule, and so on. Eventually, the lost molecule passes the energy onto the outside surface of the wall, where it is whisked away by the cold air molecules. In this way, 1 joule of heat is conducted through the wall every 5 seconds, leading to a heat transfer rate of 0.2 watts. This slide is an animation of convection heat transfer. Convection is made out of 2 parts. For the first layer of molecules, next to the cold surface at the top, you have mainly conduction, as in the previous slide. Further down, the fluid moves from the left to the right. The molecules from the left are hotter, as they are constantly replenished at a high temperature due to the movement, and hence this also represents a flow of heat in the form of advection. The con from conduction, and the vection from advection, form the word convection, which is the resultant heat transfer. Heat transfer is therefore enhanced due to the movement of the hot fluid. This slide is an animation of radiation heat transfer. The circles represent electron orbitals of a given molecule. If the temperature is high, an electron may be in a higher orbital. If it drops back into the lower orbital, this will generate a magnetic field. The generated magnetic field, in turn, generates an electric field, and so on. If the radiation hits a surface, a magnetic field may then excite an electron into a higher orbital in that surface, increasing the energy of that surface. Heat is thus transferred.